This is a video about inverse functions. Now, if you double a number, x, you get 2x. If you halve a number, x, you get half x. If you double a number and then halve it, you get the number you started with. If you halve a number and then double it, you get the number you started with. So 2x and half x are known as inverse functions of one another. Each one undoes the effect of the other. In a similar way, x squared and square root of x are inverse functions. If you square a number, like 5, you get 25. If you find the square root of 25, you get back to 5. They undo each other. Sin x and arcsine x are also inverse functions. And we can use flowcharts to find inverse functions. So for example, if we've got the function f of x equals 4x plus 5, so a function that takes a number, multiplies it by 4 and then adds 5, what would be the function that undoes that? And then the inverse function, you've just got this special notation with the little minus 1. So the inverse function is called f minus 1 of x. So representing the original function f of x as a flowchart, you take x, you multiply it by 4, and then you get 4x. Then you take that, you add 5, and you get 4x plus 5. So those are the steps that you would take in calculating 4x plus 5. So let's think about undoing everything there. Let's think about going backwards through the flowchart, doing opposite things. So we can go the other way through the flowchart and undo each step of the process. What would undo adding 5? Well, subtracting 5 would undo adding 5. And then what would undo multiplying by 4? Dividing by 4 would undo that. So we're thinking about going backwards, that is from right to left through the flowchart, doing the things that will undo all of those steps that we took in working out the original function. So if a number x went into the right-hand side of the flowchart and you subtracted 5, you'd have x minus 5. If you then divided that by 4, you'd have x minus 5 divided by 4. So the inverse function, f minus 1 of x, is x minus 5 over 4. So that means x minus 5 over 4 would undo the effect of 4x plus 5. So 4x plus 5 and x minus 5 over 4 are functions that undo each other. So we're going to use flowcharts to try and find the inverse of each of the following functions. I'd like you to pause the video and try and actually attempt these. Now beware, there's a little trick with the last two. The first two should be fairly straightforward enough, but the third one and the fourth one, there is something to think about there. So pause the video and then attempt those questions before resuming, please. Okay, so here come the answers. So the first one, f of x equals 2x minus 5. So the original flowchart for this one, you take the x, you multiply it by 2 to get 2x, and then you subtract 5 to get 2x minus 5. So we're going to try and reverse that flowchart. So the opposite of subtract 4, or the inverse of subtract 4 would be to subtract 5 rather. The inverse of subtract 5 would be to add 5. The inverse or opposite of multiply by 2 would be to divide by 2. So the reverse flowchart goes take a number, add 5, and then divide by 2 to undo everything. So a number x in there, you'd add 5 and you'd get x plus 5, and then you'd divide that by 2 to get x plus 5 over 2. So the inverse function is x plus 5 over 2. So 2x minus 5 and x plus 5 over 2 undo each other. Now we can verify that by putting in some number. So let's say put in 100. So if the original function is 2x minus 5, so f of x is 2x minus 5, then f of 100 is what you get when you put 100 in. So that's 2 times 100 is 200, minus 5 makes 195. If you now take that 195 and put it into the inverse function, you should get back to 100. So let's try that. So the inverse function, f minus 1 of x is x plus 5 over 2. So f minus 1 of 195 is 195 plus 5 divided by 2. And that does indeed give you 100 again. So it takes you back to the number you originally put in. So those two functions and the function and their inverse, its inverse, have undone one another. Okay, so we're moving on to question 2 now. And question 2 said f of x equals a third x plus 8. So representing that by a flowchart, if you take x and you divide it by 3, you get a third x. Then if you add 8 to that, you get a third x plus 8. So trying to do a reverse flowchart that undoes that in the other direction. To undo adding 8, you would subtract 8. To undo dividing by 3, you would multiply by 3. So if you take a number x, then subtract 8, you get x minus 8. And then if you multiply that by 3, well, you can write it as 3 brackets x minus 8, 3 times x minus 8. So the inverse function can be written as 3 times x minus 8. You might have written it as 3x minus 24 with that multiplied out, and that would work too. So we'll just verify that. I'm going to stick in a number. I've deliberately chosen a biggish number that divides by 3. So if the original function is f of x equals a third x plus 8, then f of 120 is what you get when you stick in 120 for the x. So a third of 120 would be 40, so that gives you 40 plus 8, which is 48. So if I take that 48 and stick it into the inverse function, it should get me back to 120. So the inverse function was f minus 1 of x equals 3 times x minus 8. So sticking 48 into that, I get f minus 1 of 48 equals 3 times 48 minus 8, which is 3 times 40, which is back to 120. On to number 3 now. So number 3 was tricky. F of x equals 6 minus x. So what you're doing there is subtracting the number from 6. So my box is saying take the number x and subtract it from 6 to get 6 minus x. Now what's tricky about that? 6 minus 4 is 2. 6 minus 2 is 4 again. 6 minus 1.5 gives you 4.5. And 6 minus 4.5 takes you back to 1.5 again. So subtracting something from itself, if you want to undo that, you subtract it from that number again. I'll just repeat that. I think I stumbled on my words. So for example, if I subtract something from 6, I take the answer and I subtract it from 6 again, I get back where I started. So subtracting something from something is self-inverse. If you want to undo subtracting a number from 6, you subtract the result from 6 again, and you get back where you started. And that's true of any kind of subtract from operation. So the inverse of subtract from 6 is subtract from 6. So the inverse of 6 minus x is 6 minus x again. So f minus 1 of x is 6 minus x. It's self-inverse. So here's number 4. F of x equals 1 over x. And there's a trick to this one, or something you need to be careful of. What we're doing here is dividing a number into 1. So we're taking the x and not dividing it by anything, but 1 is getting divided by the number. So we're taking the number and dividing it into 1. Thinking of a few actual concrete examples, 1 divided by 4 is 0.25. And if you take that 0.25 and do 1 divided by 0.25, you get back to 4 again. 1 divided by 10 is 0.1. And take that 0.1 and do 1 divided by 0.1, you get back to 10 again. So dividing something into something is another self-inverse function. So the inverse of dividing into 1 is dividing into 1. So the inverse function is also 1 over x. F minus say that again. F minus 1 of x is 1 over x. It's a self-inverse function. Okay, the next part of the video is moving on to the algebraic approach for finding inverse functions. So instead of having to draw lots of diagrams, flowcharts, there is a purely algebraic way we can do this. So we have seen how we can find inverse functions using flowcharts. However, we can take an algebraic approach. So here's the approach. Step 1, write down the function as y equals something. Step 2, interchange the x and the y. This gives the inverse function, but not in a useful form. Step 3, rearrange it as y equals something. Now that's not going to mean anything at the moment, but hopefully that will be clearer with some concrete examples. So for example, if f of x equals 4x plus 5, then find the inverse function f minus 1 of x. So in the old days, we'd have taken a flowchart approach. We'd have broken 4x plus 5 down into taking the x, multiplying it by 4 to get the 4x, and adding 5 to get 4x plus 5. We'd have then gone backwards through that process, undoing everything. So the opposite of adding 5 is subtracting 5. The opposite of multiplying by 4 is dividing it by 4. So taking an x and putting it backwards through all those reversing processes, you get x, subtract 5, gives you x minus 5, and divide that by 4, gives you x minus 5 over 4. So the inverse function is x minus 5 over 4. The algebraic approach, you take the function f of x equals 4x plus 5, and then you're just changing the notation here, and instead of calling that f of x, you call that y. So you just call it y equals 4x plus 5. It's just doing the same thing, but with slightly different notation. And then you interchange the x and the y. So everywhere you had a y, you swap it for an x. Everywhere you had an x, you swap it for a y. And that does give you the inverse function. But the problem with that is that it's not in a useful form, because you want the inverse function to tell you what to do with the x. And at the moment, you've got a function that tells you what to do with the y to get the x. So you need to rearrange it into what y equals. So first step, I've taken away 5 from both sides. Next step, I've divided both sides by 4, and then I've got the y on its own. So that was all about rearranging the equation step by step to get the y on its own, and I figured out that y is x minus 5 over 4, and that is the inverse function. So the inverse function is f minus 1 of x equals x minus 5 over 4, and that agrees with what we got from the flowcharts. Now sometimes you get questions where the x appears in 2 places in the original function, and then in those cases the algebraic approach is the best method. So for example, f of x equals 4x plus 5 over 3x minus 2. Now if you try to make a flowchart of that, you wouldn't know where to start, because you've got the x in 2 different places. So would it have 2 different start points for the flowchart? How would you go backwards through it? Difficult to do. So finding the inverse function, f minus 1 of x, you have to take an algebraic approach to this one. So here we go, here's the function. F of x equals 4x plus 5 over 3x minus 2. I'm just going to change the notation and call that y. So y equals 4x plus 5 over 3x minus 2. Then I'm going to interchange the x's and the y's. So just swapped x's for y's and y's for x's. And that is the inverse function. But the trouble with that is it's not in a useful format to us because we want it to tell us what y is in terms of x. We want a function that says calculate y by doing this, this, and this with the x. So we need to rearrange that to say y equals something, something, something with the x's. So the first step I'm going to take is to get rid of that fraction. So I'm multiplying by the denominator of the fraction to get rid of the fraction. So multiplying by the denominator of the fraction leaves me just with the 4x plus y that was on the top, on the right-hand side. But because an equation is like a balance, whatever I do to one side, I have to do exactly the same to the other side. So I have to multiply the left-hand side by 3y minus 2. That's the denominator of the fraction as well. Well, now I've got some brackets. I'd like to multiply those out to make things a bit less complicated. So I'm expanding the brackets. X times 3y gives me 3xy. I've kept everything in alphabetical order there. And minus 2 times x gives me minus 2x. So I've got 3xy minus 2x equals 4y minus 5. Now remember what I'm trying to do here. I'm trying to rearrange this as y equals something, something, something with the x's. So I'd like for all the y stuff to be on the left-hand side and all the non-y stuff to be on the right-hand side. So I'm just going to add and subtract bits to both sides now so that I've got all of the y on the left and all of the rest on the right. So getting the y terms to the left, first of all, I've added 2x to get rid of the minus 2x, but I've got to add 2x to the other side as well. Now I'm taking away the 4y from here, so I don't have any y's on the right, but then I've got to take away 4y on the left as well. And now I've got all of the stuff that's got a y in it on the left, and all of the stuff that hasn't got a y on it on the right. Just going to go up here now for space. And the first thing I'm going to try and do is to factorize, because now that I've got everything on the left having a y in it, I can factorize the y out of that. So factorizing, I can take a y outside the brackets and say that everything over here is equal to y times something. So y outside the brackets times 3x inside the brackets gives me my 3xy. And y outside the brackets times minus 4 inside the brackets gives me my minus 4y. And I deliberately got to a stage where I could do that by putting all of the y stuff on the left in the first place. So I've got 3 times and then a big bracket of stuff equals 5 plus 2x that was there before. Now to get the y on its own, all I need to do is divide by that bracket. So y on its own equals 5 plus 2x that was there before, divided by the stuff that was in the bracket, 3x minus 4. And now we're there. The inverse function is that. So putting it back in the f of x notation, the inverse function is f minus 1 of x equals 5 plus 2x over 3x minus 4. And we can just finish off by verifying that. So if I stick a number in for x, say 4 to the original function, 4 times 4 plus 5 gives you 16 plus 5 on the top. 3 times 4 minus 2 gives you 12 minus 2 on the top. So that all comes to 2.1. So if I take that 2.1 and put it into my inverse function, that should take me back to 4. So let's do that. The inverse function was 5 plus 2x over 3x minus 4. So sticking in a 2.1 everywhere where I had an x gives me 5 plus 4.2 over 6.3 minus 4, which comes to 9.2 over 2.3, which takes me back to 4 again.